Okay, I first just want to do some trig functions that don't have anything else happening to them except for the period. The period is changing. All right, but before I do that, let me show you guys really quickly what sine and cosine functions look like. You guys already know this, but it's always good to review. So, right, sine x right here. No, sorry. Yeah, sine of x. And a regular sine function has an amplitude of 1, a y-intercept of 0, a period of 2 pi. The x-intercepts we'll do later. The phase shift, there is none for the original one. And maximums and minimums are at 1 and -1. Alright, so we always put the period right here. I like this part of the graphing because this graph right here is like a graph you can manipulate and do whatever you want to it to help you guys see what the... Oops, sorry, that's my alarm. To help you guys see where all the different parts of the graph are. So, in order to label these x values, what we're going to do is we're going to take 2 pi and we're going to divide it by 4. Why do we divide it by 4? Because there's 1, 2, 3, 4 parts right here. So we're going to divide 2 pi by 4 to get... What is 2 pi divided by 4? 2 pi divided by 4. If you simplify that, you get... Okay, pi over 2. So we go pi over 2, 2 pi over 2, and 3 pi over 2. And then if we add it one more time, we get 4 pi over 2, which would give me 2 pi. This one simplifies to give me pi, because 2 divided by 2 is 1, so we get 1 pi. Then we know that our sine function goes x-intercept, 1, which is your max, back to the x-intercept, -1, and then back to x-intercept. So we have a curve that looks like this. This is our sinusoidal function. It goes center line, max, center line, min, center line. If we know this, it makes graphing the transformations or the translations or shifts a lot more simple. The x-intercepts we'll get from this graph right here. Now, because this graph doesn't have very much change, we can easily just throw in our points onto this and we get the same thing. Okay, not much difference here. Let's see. Anything else I want to say? Oh yeah, so when you go from here to here, just do it by individual points. Now let's look at our cosine function. Oh wait, our x-intercepts. Our x-intercepts here, because this one doesn't go up or down, we can list our x-intercepts as 0, pi, and then 2 pi. Alright, let's look at our cosine function. I'm going to go down to the next one so we can do our cosine function. The cosine function, let's see, y equals cosine of x. The amplitude is 1, the y-intercept is 1, period is 2 pi, the phase shift there is none because there's no h. Okay, so since it's 2 pi, everything is the same. We're going to count by pi over 4s, so we get pi over 4 right here. We get, I'm sorry, not pi over 4, pi over 2. 2 pi over 2, and then 3 pi over 2. Now, if you remember our cosine functions, we know that it starts at 1. And then it goes to the center line, then down to -1. That's our minimum. Then back to the center line, the +1. Our cosine function looks like this. When we translate that over to the other graph, it's not very difficult because there's not much change or anything special going on here. I put my points on first, and then I graph. Okay, so we have our x-intercepts, and this one is just pi over 2 and 3 pi over 2. Our max is 1 and our minimum is -1. That's how you graph the basic sine and cosine functions. I'm going to repeat that, Omar, because that was a good question. You asked, how can we know we start at 1? We spend a lot of time in the unit circle, so think about our unit circle. When we look at our unit circle, at 0 degrees, which is right here, that's right here, this is 0 degrees, what is our x? We know that x is cosine, our x is 1. And so we start on 1. For sine, we start on 0. That's the y value. That's why sine starts right there. That's another good comment. Thank you, Omar. So at pi over 2, you guys can see that we're at 0. And that makes sense because when we go to the angle pi over 2, we're at 0, 1. Our cosine is now 0. And so remember, the unit circle tells us the values of the cosine function as the x coordinates in the unit circle.